Welcome to the first video in Math 6. Today's learning target is that you will be able to identify the difference in a prime and composite number and know which numbers up to 30 are prime and composite. This should be review for you. So what exactly is a prime number? A prime number is a whole number that has two factors, only one in itself. So let's take a look at the number 2 here. 1 times 2 equals 2. There are no other factors other than 1 and 2, so this is considered a prime number. Okay, so let's take a look at another example. 12. 6 times 2 equals 12, or 3 times 2 equals 12, and we could also say 4 times 3 equals 12. So 12 would not be considered a prime number. So what exactly is a prime number again? It's a number that only one in itself goes into. So here are some examples of a prime number. 1 times 2, 1 times 3, 1 times 5, 1 times 7, 1 times 11, 1 times 13, 17, and 19. Those are your prime numbers up to 20. Please go ahead and fill these out in your notes. Pause the video if you need to. So what is a composite number? A composite number is a number that has factors other than 1 and itself. So some examples of a composite number. Let's take a look at the number 16. We have 1 times 16 equals 16, 2 times 8, and 4 times 4. So 16 is a composite number. So what I want you to do is pause the video and write down the composite numbers between 1 and 30. Okay, thank you. I hope that you have written those down under your example. So let's go over them. 1 times 1, so we know it's not 1. 2 was composite, or I'm sorry, prime, so we know 2 isn't. 3 was prime, so 4. 4 would be considered composite because 1 times 4 and 2 times 2, so 4. Okay, 5 is prime, 6. Okay, then we have 7 is prime, 8, 9, because 3 times 3 equals 9, 10, 11 is prime, then we have 12, and then 13 is prime, and then we have 14, 15, 16, we also have 18, 20, 21. All right, and then we would also have, I'll write them up here, we would also have 22, 24, 25, 26, 27, and 28, and 30. So those are all of the composite numbers up to 30. So let's take a look at some of the composite numbers here. You can see some of the factors up to 20. So we have 2 times 2 for 4, 2 times 3 for 6, 2 times 4 for 8, 3 times 3 for 9, 2 times 6 for 12, and 3 times 4, 2 times 7 for 14, 3 times 5 for 15, and then 2 times 9, or 3 times 6 for 18. So these are all of the composite numbers up to 20. Well, and then 20 would be one as well. So right here we're going to look at this interactive activity where we can see if numbers are prime or composite. We've already discussed how 4 would be considered a composite number, so I want to show you what happens if I try to put this into prime. Notice it does not go in there because 4 is a composite number. So when I move it over to 4, notice that it goes away. Okay, 24, I want you to think about it. Can we divide 24 by 2? Yes, we can. It would be 2 times 12. So since that has factors other than 1 and 24, that would be considered a composite number. 9, we can do 3 times 3, so that would be composite. 16, that would be 4 times 4 or 2 times 8. 12. 12 would be 3 times 4 or 2 times 6. 39. Now say 39, I'm not quite sure. We definitely need to know our prime numbers up to at least 20, if not 30. I know that 3 times 13 equals 39, so that would be a composite number. 2 times 4 is 8. 3 times 10 is 30. 1 times 3, there's nothing else that goes into that, so that would be prime. 1 times 13, we also discussed how that one was prime. 1 times 2, so that is prime. 1 times 11, so that is prime. Only 1 times 29, 1 times 23, 1 times 5, and then 1 times 17. So those are all the prime numbers. So what you should be able to do at the end of this section is you should be able to say, I can identify the difference in a prime and a composite number and know which numbers up to 30 are prime and composite. All right, the second learning target for today is that you'll be able to use a factor tree to break a number down into its prime numbers. So let's take a look at this. What is prime factorization? A factor tree can be used to get a number down to the prime numbers. Prime factorization is used for simplifying fractions, finding the greatest common factor, and the least common multiple. So let's take a look at 24. We could say, well, 6 times 4 equals 24, so we break it down into two numbers, okay? And then we're going to break down each of those until we get to prime numbers. So remember, prime numbers are a number that only one in itself goes into. So 3 times 2 equals 6, and then 2 times 2 equals 4. So notice all these numbers are now prime. So we have 3 times 2 equals 6, times 2 equals 12, times 2 more equals 24. So this bottom part here equals 24. Notice the middle part, 6 times 6 also equals 24. So we know we have factored this properly because each level equals 24 and we're down to our prime numbers. So let's take a look at 56. 2 times 28 is 56. So we cannot break down 2 any further because 2 is a prime number. So now we have 14 times 2, that equals 28, and then 7 times 2, that does equal the 14. So we've broken down all the numbers and we're down to our prime numbers. So now if we do 7 times 2, we get 14, times 2 more, we get 28, and then times 2 more, we get 56. So 7, 2, 2, and 2 are our prime numbers. Let's take a look over here at 56. This is another way to break it down. So we have 8 times 7, which is 56. We're going to break down 8 to 4 times 2, and then 2 is prime, so we don't have to do anything else with that. And then we have 4. 2 times 2 equals 4. So our prime factorization is 2 times 2 times 2 times 7. Notice that it's the exact same as what is over here. All right, so what we're going to do is we're going to do an example. Okay, so we have 18. Okay, so I'm going to go ahead and I'm going to break down 18. Here we can do 2 times 9. I like starting with the lowest number that I know can go into it. All right, now we're going to say, what can I divide 9 by? Well, I can divide it by 3. So now 2 times 3 equals 6 times 3 more equals 18. So the prime factorization for 18 is 2 times 3 times 3. Let's look at another example here. We have 66. So again, I'm going to divide by 2 because I find that to be the easiest to do. So 2 times 33 does equal 66. Now I need to break down 33. I cannot divide by 2 because this is not even. So I'm going to divide by 3. 3 and 11. Now these are our prime numbers. So the prime factorization is 2 times 3 times 11. All right, here are some more examples. Go ahead and pause the video if you'd like to go ahead and practice a few of these on your own. So I'm going to do 16. Again, I'm going to start with 2 because it's even. So 2 times 8, and then I'm going to break down 8, 2 times 4, and then I'm going to break down 4 into 2 times 2. So my prime factorization is 2 times 2 times 2 times 2. Let's look at another example. I have 60 here. So 2 times 30, and then I'm going to break that down. 30. 30 is even. Any number that ends in 0 is even. So I'm going to divide by 2 again, and 15. Now I'm going to break down 15 into 3 and 5. So 2 times 2 is 4, times 3 is 12, times 5 is 60. So I know I did it right. So this is my prime factorization. And for the last one, I'm going to do 100. So I'm going to do 2 times 50, because I like starting with my smallest number, 2 and 50. And then I'm going to break down 50. Again, because it ends in 0, this is a even number, so I can divide by 2. 2 and 25. And then I can divide 25 by 5. So my prime factorization is 2 times 5 times 5. And there should be another 5 right down here. So I'm going to go ahead and add that. So 2 times 5 times 5 times 5. Okay, now what I want you to do is pause the video here if you would like 5 extra credit points. And what you need to do in this sheet here is you need to identify all the ones that are not broken down into prime factorization, or the ones that were not done correctly. So as an example, this one right here, number 6 here, this one is not correct because 9 can be factored down further. That's just one example. So I'm going to go ahead and leave it like this for a moment so that you can pause the video and work on these. And I'm going to scroll down a little bit so you can do the rest of these. Okay, again, pause the video if you'd like to work on the lower ones. Okay, so now at the end of this section, you should be able to say, I can use a factor tree to break a number down into its prime numbers.